Oh, sorry guys. I'm gonna finish chewing. Barbecue Lays are so good. All right, guys, today we're gonna start learning about energy. Energy is our next chapter. Now, there are two basic forms of energy. Those forms are called kinetic energy and potential energy. So, let's talk about them both. First of all, kinetic energy. This is energy in motion. That's right, as this tennis ball is moving around, this has kinetic energy. Energy in motion. Now, the second thing is potential energy. Potential energy is known as stored energy. How do you store energy? Well, you store energy based on an object's position. Right now, this tennis ball has stored energy. So, why does it have stored energy? Because its position. If I drop it, kinetic energy. And based on its chemical composition. These potato chips have chemical potential energy. So, potato chip potential energy, and we're a position of a tennis ball potential energy. So, mostly in this class, we're going to talk about chemical potential energy. So, chemical potential energy, that's what we're going to talk about the most. So, let's go back to our Lay's potato chips. Now, these have energy in it, stored energy. What do we call stored energy? Potential energy. And when it's stored in a chemical, we call it chemical potential energy. Now, there's no special gun or piece of equipment that I can shoot at this to get me a reading on how much energy is inside my Barbecue Lay's potato chip. However, what we can do is release the energy from this and see the transfer of that energy, out, and that's what you're going to be doing in a lab. So, remember kind of this setup because this is going to be part of it. So we can see this energy being released. How is this energy released? How do we do that? Well, I got my potato chip here and I got a lighter. We're going to light it on fire. This would almost be tragic if it wasn't because of a chemistry experiment because, man, these are good. I don't want to burn them. So as we can see, I'm lighting it. And okay. If we can take a closer look here, we can see that the potato chip is on fire. All right, this lovely thing is on fire. Here we go. Woo! It is on fire. Now, burns pretty well, doesn't it? Don't try this at home, people. It'll burn down your house. And you should eat these. You shouldn't burn them. So I'm going to blow that out and hopefully don't set off the fire alarm. So these potato chips will burn. All right. Now, how much energy are in these potato chips? Well, it actually tells you on the back. There's a unit that you are familiar with. That unit is calories. Yes, when they talk about calories, they're telling you about how much energy is in the food you're eating. In this case, for one serving size, so one container is one serving size, this thing has 160 calories. 160 calories. So that's how much energy is in all these potato chips. All right? Soon you're going to be learning how to figure out how much is in one thing that you burn. Now, you won't be burning potato chips. You'll be burning cheese puffs. So I talked about energy being transferred, right? We can't measure directly. We can see the transfer of it. So what is the transfer of energy called? Well, energy travels from something that's hot to something that's colder, right? So something that's a higher temperature from something that's a lower temperature. Now, what's that called? We call that heat. Heat is the movement of energy from higher temperature to a lower temperature. That's what heat is. So what we're going to look at now is I'm going to heat up some water here. Now, with the water that I'm heating up, we're going to see what energy does to water. So let's look at it. All right, so I've got my hot plate here, heating up some water. The energy is going from the hot plate to the water. And we can see that what's happening to our temperature? You can see that the temperature is going up. All right, so we see that temperature going up. All right, so energy, when transferred to water, can heat up the water, meaning it causes the temperature to go up. Now, this is not the only thing that energy can do to water. We have a second hot plate over here, and hopefully you see here that this water is boiling. Now, I want you to notice the temperature for this one. Okay, here we go. Temperature for this one, 99 degrees. 98.6. Oh, it went down a little bit. 99. All right, so it's just staying right around the same place. So you're going to see that this temperature is not really rising now. It's kind of staying in the same location. So, why? Well, heat, when it goes into water, is going to do one of two things. All right? Energy, when it goes into any substance, is going to do one of two things. It's either going to cause the temperature, or cause the substance to rise in temperature, or it can change the state of the substance. In this case, our water here is boiling. Now, I've talked to you about this in class, and now we're going to experiment a little bit. We can see here that's 99, okay? So 99 was our boiling point here, and it's kind of boiling a little bit. What I'm going to do is I'm going to crank this knob up. Hopefully I'll zoom in here. You can see this is set at 6. I'm going to crank this all the way up to 10. All right? I'm going to crank it all the way up to 10. So I'm going to keep adding. I'm going to add more energy to it. And I want you to notice, and we've talked about this, what happens to its boiling point. All right, let's look back at it. So this thing now is boiling like crazy, right? You can see it. It's boiling really fast. We can see it's still set at 10. So we're adding even more energy to it. And the temperature is still at 99, 98, 99. So as you can see here, as we're adding more and more energy to this, water's boiling point doesn't change. And so all this energy now is going from taking the water from a liquid state to, I don't know if you can see some of that steam coming off here, but to a gaseous state. So, energy is going to do one of two things when it goes into a chemical. It's going to either raise its temperature up, or it's going to change the state of matter that it's in. Those are its two options.